Okay, so we are starting this week's Excel lab. So recall our running example for simple linear regression was to look at the relationship between miles per gallon and horsepower. So we have 32 observations here. Recall that we want to estimate miles per gallon from horsepower. So I've got a series of tables here. So when you're doing your homework, you can basically just take this template and update as needed. So when we work through the second example, as usual, I'll just show you how to do it in the shortcut method so you can streamline everything. So let's start with some summary statistics for each of these. So mean, variance, covariance, and correlation. So let's first get the mean of miles per gallon. So we would say this is equal to average, and then we just select our data for miles per gallon. So A2 to A33, enter. Horsepower. Horsepower, we would do equals average, select horsepower data. B2 to B33, enter. Variance, so we would do equals var.s, select our data, so miles per gallon. And then same thing for horsepower, I do equals var.s, horsepower. And we get our variance. So these numbers hopefully look familiar from our lecture notes. So now the covariance, so this would be equals covariance.s, so covariance.s. And now we can just select both sets of data. Or actually, we need to select the first one, so miles per gallon, comma, select the horsepower. Select horsepower, close parenthesis, enter, negative 320. And then correlation, so equals correl, so correl, open parenthesis. So same thing, select miles per gallon, comma, horsepower. Close, enter, and we get a correlation of negative 0.78. Okay, so let's visualize this with a scatter plot. So recall that if we just select our data, so we would do insert scatter. So I would go down here to scatter plot. And I actually want these to be flipped in terms of, so let me go to, if you right click on the chart, select data. So I actually have these backwards. So for X values, notice that X values have miles per gallon. So this is A. And then Y values, we have horsepower, B. So where you see this A here, just change this to a B. Oh, hold on, let me redo that. I made a mistake. So right click, select data. I'm gonna just get rid of this A and write B. And then I'm gonna get rid of this A and write B. And then for the Y values, I'm gonna change this B to an A. And then I'm gonna change this B to an A. And that should just switch the axes. So now we have horsepower on the x-axis, and we've got miles per gallon on the y-axis. So let's go ahead and add some labels to all of this. So let's start with perhaps a chart title. Let me make this bigger. So this is a scatter plot of miles per gallon and horsepower. So I might want to make this a little easier to read. I might increase the font. Now let me go to chart design up here to add chart elements. So chart design, add chart element, axis title. So let's do a horizontal. So this is, I'm going to say X equal to horsepower. Again, I like to just make it a little more legible. I like to make it a little bit bigger. Okay, and then I'm going to go back to chart design, add chart element, axis title, vertical. So let's go ahead and call this Y is equal to miles per gallon. And I'm going to make this bigger as well. All right. So now we might want to add that trend line, our estimated regression line. We're going to do it all by hand, right? We're going to fill out our tables to get our equation. But if you just, again, go to chart design, chart element, and then go down to trend line. And then on trend line, we just want to do linear, right? We've been doing simple linear regression. So let's go ahead and select this linear option. And we get our regression. Now, I kind of want to distinguish it from the dots, so I'm going to make it a different color. So I'm going to right-click on it, and I'm going to say Format Trend Line. So I right-click on the line, Format Trend Line. So now I have all these options down here. So what I could do, notice on this tab, it says Display Equation on Chart. So how about I just select that? So now we get the equation. Now I'm going to go over here to the paint symbol, click on that, click on solid line, and I'm just going to make it a different color. How about we make it red? And now I'm going to close this out. So we've added our trend line and we've added the equation. I'm going to make it bigger so we can actually read it. And there we go. So we can see we have our negative relationship between horsepower and miles per gallon. We've got our lines slope downward, and we have our regression equation. Okay, so I want to put this to the side for right now, so I'm just going to, move it over here. Yes, typical Excel, moving it way further than I intended. Let me just leave it right there. Okay, so now let's calculate our coefficients. So to do that, we need to calculate our sources of variation, our sum of squares. So notice I've added these extra columns that we need to fill out. So we need to first calculate our explained. All right, hold on just a moment. Okay, sorry about that. We're going to calculate our B1 coefficient. So we do that. Recall that B1 is equal to the covariance divided by the variance of X, so the variance of horsepower. So let's start with the slope. I'm going to say equals. So it's going to be equal to the covariance. So I click on this cell, and then I'm just going to divide by the variance of X, which would be this cell, the variance of horsepower, 4,700, and enter. We get negative 0.0682. And then let's remember that for B naught, it is the mean of y minus B1 times the mean of X. So that means this will be equal to equals average of miles per gallon, right? Average of y bar, minus B1, so B1 times the average of X, or horsepower, so mean horsepower. Enter. And we get our coefficient. So let's go ahead and write our equation. So this would be miles per gallon is equal to 30.099 minus 0.0682 times horsepower. Okay, so now we can calculate our sources of variation. So we need to calculate our predicted value of miles per gallon. So that's just plugging into our formula. So that's going to be equals our intercept, and then it will be plus our coefficient times our x value, so horsepower, enter. Now remember, we want to lock this the coefficients in place, so I'm going to put a dollar symbol in front of J and 11 as well as J12 because I don't want those to change. The only thing I want to change is what's here in purple, which is the horsepower, our x value. Enter. Drag that down, and we get all of our y hats. So now we can calculate our residual, which is our actual value of y minus the predicted value, or rather predicted minus actual. So this will be equals predicted minus actual. So predicted versus MPG. So we get a positive 1.5, and we can just drag this down. So squared residual, so that'll just be equals this squared. So it's just equal to the residual squared. So I'll just say equals that, caret 2, enter, and we drag down. And then for explained variation, this is y hat minus y bar. So this would be equals, so I'm going to write parenthesis, predicted value, y hat, minus y bar, which would be the average of miles per gallon. So I'll click on this, close parenthesis, caret 2 to square it, and then I want to lock the average of y in, so I'll say dollar symbols in front of the I and the 4. And we get our explained variation. Okay, so if you're confused at this point, just remember you can always come to this file and just look at the formulas. And if you click up here in the formula bar, it'll highlight all the cells that I am referencing. And I'll actually show in the next video how to create all of this where you don't have to actually write all of these equations. If you just copy paste, it'll update everything automatically. It's just important that we know how to do this by hand as well. So then we want to find our sources of variation, so the total. So SSE is the unexplained, so that's just the sum of the residual. So I would say equals sum of squared residual. So I'm just going to say sum this column, close parenthesis, enter. SSR, so that's explained variation. So this would be equals sum of our explained variation. So it would be the sum of this. And then SST is SSE plus SSR, so I'll just say equals SSE plus SSR, enter. And all of these numbers should be the same as before. By that I mean from our lecture notes. So coefficient determination, remember we can do it 3 ways, so I'll just show you how to do it all 3 ways, but you only need to do it 1 way. So I usually just do SSR over SST, so this would be equals SSR divided by SST, enter, and we get our 60%. But remember, we could also do equals 1 minus SSE, so I'll do parenthesis SSE divided by SST, and that would still give us 0.6. And finally, we could have just squared our correlation, so I could say equals correlation, so I'll say correlation, caret 2 to square it, and all 3 methods give us the same value, but again, you only need to do this 1 way. Okay, if we wanted to do some prediction, so for some new values, we could just do the same thing as what we did here for predicted miles per gallon. So I will say equals intercept plus slope coefficient times 150, that value, enter. Of course, I'm going to want to lock in our intercept and our slope, so I'll put dollar symbols in for our J11 and J12 so that I can just drag this down and get predictions for 200 and 250 as well. So I think we did 200 and 250 in the lecture notes. I also added 150 here as well. Okay, standard error. This one's a little bit more of a pain. Okay, so it is equal to. So again, this you can just copy paste for future reference, but let's go ahead and do this by hand once. So equals, so square root function. So I'm going to open up 2 parentheses, And recall that it is equal to SSE divided by n minus 1 degrees of freedom. So I'm going to use equals count. I'm just going to count up the number of observations I have. Close that, minus 2. Close parenthesis, divide by the variance of x, which is horsepower. Close the last parenthesis, enter. And yeah, of course I made a mistake. I needed a parenthesis here and a parenthesis here. Okay, there we go, and I get my test statistic. So T-stat is just B naught, or B1, so equals B1 divided by standard error, and we get our negative 1.21. T critical value, so this would be equals T dot inverse, so 1 minus 0.05 divide by 2, and then n minus 1 degrees of freedom, so count. The reason I'm using the count function is so that you don't actually have to worry about it. If you just streamline your homework, you don't have to update the degrees of freedom. It'll do that automatically. P-value, so this is T equals T dot dist dot 2T. So it will be absolute value of T stat. So T stat. So absolute value of T stat. And then comma, I'm going to do count. So n minus 2 degrees of freedom. And we get a p-value of 0.23. And then finally, our confidence interval. So this would be equals B1 minus our T critical value times our standard error. And then the upper would be the same, except we would use a plus. So I'm just going to copy paste this in, except instead of minus, we're doing plus. Okay, and there we get our confidence interval. So the last thing I just want to do is quickly create some residual plots. So our residual plots, we want to compare predicted values with residual values. So how about we just go ahead and select these data, and then, so I'm going to select this and then do insert scatter plot. And we get our scatter plot. So let's say scatter plot of fitted values versus residuals. So let me just add some axis titles. So on the x-axis, we have fitted values. And on the y-axis, we would have residuals. So just recall, we use this to check our independence, homoscedasticity, and linearity assumption of our residuals. And then finally, we want to check normality of residuals. So I'll just highlight the residuals and then do insert histogram. And I might call this histogram of residuals. And we can see this is mostly normally distributed, thereabouts. Okay, so that was a lot, I know. This was a long video, but in the next video, I'm going to show you how to do all of this very quickly. So you don't have to go through this whole process again. You can just update a few things and do your homework very quickly.